Good afternoon, everybody. It's really great to see you all here. For those of you who saw my talk yesterday, you're going to see some snippets that will look familiar to you, but I'm going to tell you a lot more than what I got into yesterday. I will say, first off, that it's always hard following up after a robot, so I really wish I had brought one with me. Maybe next time I come back here, I'll bring not just one, but two or three or four. I will say that the prior talk was also a really great setup to this talk, because one of the things it got into was this whole question, the whole notion of how humans and robots can really work together, how they can interact, how they can function as a productive team. And I think that is a common theme for us at NASA, is really trying to understand not just how robots work or how humans work, but how they work really well together. So what I'm going to tell you about for the next 15, 20 minutes or so is some of the work that we've been doing at NASA to really create out-of-this-world robots that really support human-robot teaming, that really help us create better ways of exploring living and working in space. To start with, we have a lot of good examples of what human-robot teams might be, both in terms of the way we see them in science fiction, and you can probably guess what my favorite movies and shows are, to things we see in the real world as actual examples of how robots are used today. One of the things that you'll notice is that in science fiction, there's this notion that they can work seamlessly together. You can talk to the robots, they talk back to you. Not really the state of the art today, at least in real world applications, but much more that robots are used as tools or extensions of humans. As we're looking for space exploration, however, one of the things we do want to understand is how can we take advantage of these different models of working with robots. There are many ways to form a team. Obviously, using a robot as an extension, as a tool, is something that NASA has done for a long time. We've had these large robot arms on the space station, and before that on the space shuttle, that we use to move payloads around. But there are other ways to think about teaming that allow humans and robots to be closer, more like partners, more like peers. There are also interesting questions about how you use robots. I mean, you could certainly take advantage of different forms, different shapes of robots, different capabilities, and all those are the kind of things that we care about in terms of research and development at NASA. I'm going to tell you about two specific use cases, and I think the takeaways from here are that these are just the tip of the iceberg of different ways to put humans and robots together. One is how we're using robots to improve human exploration, that is working with astronauts, and the second is using robots to improve the way that we take care of human spacecraft, the places where people actually need to live and then work. One of the other ways of doing this, however, is to start thinking about the different ways you can put robots and humans together. It's not the case that you can only think of robots working side by side in real time with humans. In fact, I think it's a lot more productive to think of the full range of things that you can do. So one of the things we've been looking at for a number of years within NASA is the idea that robots can form teams with humans across space, across time. The idea is you could have robots working before humans, robots that work in parallel or support, and robots that can come after humans. The idea here is that don't think of a team as one static thing, but rather a whole different wide variety of constellations and configurations of ways of putting peoples and humans together, robots and humans together. Yesterday, I talked a little bit about this idea of having astronauts in orbit controlling robots on a planetary surface, the idea of making Avatar become something useful in real life. We've been doing this for a while at NASA, trying to understand how do you build the system there, what are the requirements in terms of the interfaces, the communications, the robot capabilities. And I showed this video yesterday. I don't know if it's got sound.
Prepared to command a robot on the ground in California. That's part of the surface Telerobotics investigation, looking into how the human crew on board an orbiting vehicle can command robots, which are hundreds or even thousands of miles away on the surface of a planet or asteroid or the moon, in order to have those robots perform tasks that will help the people explore those places.
So the overall idea about this, of course, is that you have a robot that has a certain set of capabilities, certain limitations, and you use the human to help compensate for those limitations. So when the robot gets into a difficult situation, maybe something beyond what its onboard autonomy can handle, you loop in the human provides high-level guidance. And so we refer to this, of course, as astronauts remotely helping space robots. This is really, I think, an important thing as we are trying to create robotic systems, to realize that there are always places where the onboard autonomy is going to be limited, at least probably within the foreseeable future. Now, maybe if we fast forward another 50, 100 years, we'll have systems that are really capable of learning and adapting. But the reality is, at this moment in time, our onboard autonomy, the systems that we build for robots, are going to be limited. And therefore, we need to find ways of addressing the anomalies, the corner cases, the edge cases, the kinds of things which pose problems to onboard autonomous systems. One of the things that we've seen, of course, is that when you have a human working with a robot, it's really important to think about what information, what data do you collect from the robot and then provide to the humans. Because, of course, humans and robots look at the world very differently. Robots make use of sensors. The data is very quantitative in nature. You need to find ways of converting that into ways that humans can understand, especially rapidly. And so part of that is the use of 3D user interfaces, we feel is a very important thing in representing the state of the world. These are the kinds of systems that we've been spending a lot of time developing. And as I said yesterday, we've also tried to take this and apply this to different cases. So the idea that we can go from just astronauts working with robots remotely to the cases here on Earth where you might have humans supporting, for example, autonomous vehicles. This morning, I know in this particular stage, there's a lot of discussion about what is the state of autonomous vehicles in terms of safety, in terms of operations, whether you get from level 1 up to 5 and then the next 5, 10, 15 years. I firmly believe that one part of that evolution is really looking at how humans can remotely support these autonomous vehicles as we get into near-term deployed applications. And the reason for that is that, as I think all of us who drive recognize, is that it's difficult to deal with a lot of situations. I mean, you face these situations where it's really difficult to understand which way do you go. I mean, look at the middle example here. I'm not even sure if I was driving which way I would decide to go. Whether it's left, right, probably just stay in the same place. Over on the right side here, the situation that you face all the time when you drive, towards the sun. These are situations that are difficult for humans to deal with, and I guarantee are really, really difficult for a robot, especially if that robot is a car, to cope with. And so one of the things we've been doing is working with various different organizations doing development. Last year we did a lot of work with Nissan. Is there any way to reduce the sound? Thank you. This is a demonstration of work with Nissan. This is a live feed of showing what happens when a vehicle reaches a place on the road where there's construction. You can see in the top right image there's a construction here. At this point, the car doesn't know what to do, and so it's communicating with a mobility manager. This is Richard here, who's looking at a 3D view, live sensor data. He's trying to determine what to do to get around this. It's trying to solve a problem that the onboard car system's unable to solve, because the solution really relies on driving on the wrong side of the road, basically breaking the law and driving on the side where opposing traffic normally comes. So he's using his human understanding of the situation, the fact that it's a construction site, to provide high-level guidance to the robot, not real-time joysticking. He's just saying, well, it's acceptable to drive on the other side of the road, and so he's going to basically paint this secondary road and send this as high-level guidance to the vehicle, which then carries it out, but still maintain its onboard safety to avoid obstacles and to watch for oncoming traffic. This sort of interaction, which can be very fluid, is something that we've been working on with Nissan North America for the past couple of years. It's something I think is going to be really needed, especially for near-term applications where if you're looking at driving mobility services for people or transport of various packages and delivery services. So that's some of the work we've been doing to try to look at how you can really team humans and robots directly. The other area that I said is a good use case is the whole question of how you use robots to just take care of things that we care about. And in space, the number one thing that astronauts care about, of course, is their spacecraft. One of the big challenges we face, of course, is how to maintain spacecraft in good shape. Some estimates today, for example, say that astronauts spend upwards of 40% of their time on the space station taking care of the space station. Now, 40% is a lot of time if you think about that. That means 40% of the time that cannot be spent on other things, such as performing science experiments, for doing technology demonstrations or testing. 40% of the time when you're just maintaining the environment. And so one question that we have been asking ourselves is, can we do this robotically? Are there things that we can offload from humans to robots, especially to take care of the environment? And one of the things we've been developing over the past several years is a whole series of free-flying robots. And I'll start off by showing you one of the early free-flying robots that's been on the space station for about 12 years. Now it's called Spheres. It was originally developed at MIT, and NASA's been using it for a lot of technology development. You can probably guess where this comes from as well. So about 12 years ago, Dave Miller, professor at MIT Aeroastro Department, challenged his senior design class to build him a Jedi lightsaber trainer. And that turned into this, which are the Spheres robots. There are 3 of these on the space station. They are used more often than any other facility on board the space station for doing research and development. We've used them for all kinds of different tests in terms of formation flying, rendezvous and docking, carrying payloads, autonomous navigation. It's been a really great research platform. And then about 7 years ago, we decided to start trying to make them more robotic in nature, at least in terms of modern robotics. And the first thing we did was we upgraded them by adding an off-the-shelf smartphone, which we actually purchased at Best Buy of all places, modified, sent it to the space station, added it to the robots, and that turned us into this new system here called Smart Spheres. So you can see on this image here on the very left side, there's actually a smartphone hanging off the spheres. Basically a brain upgrade that we did because it had a high bandwidth wireless, high performance computer processor on board, cameras, IMUs, additional sensors. All this enables us to turn a fairly old free-flying robot into a new one. And we use this robot to learn a lot about how to develop and use free-flying robots on board the space station. In particular, for monitoring the environment, for understanding what needed to be fixed, understanding the overall state of the vehicle. Here you can see an example of some live data that we streamed from the space station down to mission control. You're seeing live feeds of camera images. You see a preview of the path that the robot is flying in a very autonomous manner. This is the kind of operation that's really important for taking care of spacecraft in orbit, but we also believe this kind of information is going to be needed for taking care of habitats that we might build on other planets. So that was Smart Spheres that we worked on for a couple years, and then over the past 3 years we've been developing the next generation robot, which is called Astrobee. Astrobee is a robot that's been in development at NASA Ames primarily, although there's been some joint work at Jet Propulsion Laboratory and working with other people across the nation in various universities. For us, Astrobee represents the latest robot that we are building for the space station, and it's meant to be a production system. So in contrast to Spheres and then Smart Spheres, which were used primarily for research, this is going to be one that we use to actually take care of the space station. Astrobee is going through a development process right now. We're actually producing the flight units as I speak, and we are intending to launch this in November. And once Astrobee gets on the space station, we'll be able to use it for a number of different things. Astrobee is equipped, for example, with a number of different processors. There are 3 smartphone-class computers on board. It has a number of different expansion ports, so people who are interested in building different hardware payloads can integrate it to the robot. It has an arm on it that allows it to grab onto handrails and hold itself in position on board the space station. And it's going to be a very flexible system for carrying out a number of different tasks that really help take care of the spacecraft. A mobile sensor for looking at the environment, a remotely operated camera to allow mission control to have better understanding of things on board the space station, and of course it will still be useful for zero-gravity robotics research. One of the core things here is the idea that it's a free-flying robot that can go anywhere in the space station, and it can do that autonomously, so that you don't require astronauts to position it, you don't require even mission control to have to joystick it, but really you can tell it where to go and to carry out various functions in a fully autonomous manner. As I mentioned, one of the core things we're interested in is this idea of using it as a mobile sensor. One of the most important things I think about looking at any sort of environment that you might want to take care of is understanding what is the state of the environment. What is the light level, the air quality, sound levels, radiation, all those kinds of things require mobility, requires mobile sensing. And although you might rely to some extent on fixed sensors, there are places if you're trying to, for example, understand the state of the air in the middle of the space station, you can't just hang sensors everywhere. You need something that is mobile. And for us, a free-flying robot is one solution for that. We're also taking a look, as I mentioned, in terms of the idea of providing better situation awareness, better understanding to people in mission control. On board the space station, for example, right now we routinely rely on fixed cameras that we tell astronauts to reposition. It's a very tedious manual process, and we'd much rather have a camera system that we can remotely operate, that we can send to various places, that we can support the astronauts, that we can look at different experiments, and that we can use really just to have a better understanding of what's going on at any given time on board the space station. The third area that I mentioned is in terms of zero-gravity robotics research. Just like Spheres has been the most popular research facility on the space station, we're designing Astrobee to be one that will support a wide range of experiments. So if any of you out there, for example, says, hey, I'd like to build something and have it flown in space, well, this is a good target platform for you. It's designed to have a payload bay that we can add on different instruments, different mechanisms, different devices. It has an open source API, which we released a few months ago. It's actually available on GitHub. You can actually download pretty much the entire Astrobee flight software stack, and you can develop software payloads or hardware and software payloads to run on this robot. What I'm going to show you now is just a short overview video to give you a better sense of what Astrobee is going to look like. As I said, we're launching it to the space station in November, so this is really a sneak preview of what we believe the robot's going to look like once it's fully launched to the space station and operational.
Flying more than 250 miles above Earth, the International Space Station is both a research lab and a stepping stone for future trips to the Moon and Mars. NASA is developing 3 Astrobee robots that will fly inside the space station alongside astronauts, opening research opportunities for guest scientists, and saving astronaut time by doing routine tasks. The Astrobees will replace the spheres, the current robots, and most used ISS payload. Fully autonomous, each 1-foot cube is packed with sensors that open up new areas of research. The Astrobees provide a zero-G research facility for guest scientists, give ground controllers additional eyes on the spacecraft, monitor radiation and air quality that help keep astronauts safe, and can even find lost items. The built-in arm normally occupies the top bay, but can also be swapped for a guest scientist's own experimental hardware. Like a quadcopter, Astrobees fly in air, except there is no gravity on the ISS. As a result, they are not limited by lifting power. Larger payloads can attach in a tractor-trailer configuration, and multiple Astrobees can even work together. 2 centrifugal impellers drive air through 12 adjustable nozzles that work together, allowing the robot to instantly move in any direction and turn on any axis. The Astrobees will continue the Sphere's tradition of hosting the annual Zero Robotics competition, drawing together thousands of students from 18 countries who can watch their code fly on the space station. Launching in 2018, Astrobee is the next-generation robot meant to make life in space easier for astronauts and, at the same time, build a foundation for new scientific breakthroughs in autonomy and robotics.
I think one of the key takeaway messages about Astrobee is that it uses virtually only off-the-shelf components, with the exception of the propulsion system, which is custom designed for the space station in terms of the way that we pull air in and blow air out to fly around. Every other component on board the Astrobee is off-the-shelf. We use off-the-shelf processors, off-the-shelf sensors. As I mentioned, the software we released open source. It's really designed, I think, to take advantage of really the tremendous development we've seen in the commercial industry and in the robotics community. And I think one of the core things that I'd like to encourage all of you to think about is if you have technology that could possibly be tested in space, you could have use for NASA purposes as a development area, as something that you might want to get interested in and try out, please contact me. NASA is really open to trying out new kinds of technology. Astrobee is meant to be an open platform for that, and we're really looking forward to seeing this fly in just a few months. With that, I see I'm actually out of time, so thank you very much. If you have questions, please come find me afterwards. There is a short, I think, press briefing in like half an hour that I'm doing with Mike Massimino, former NASA astronaut, and then after that, I'll be around the show for a little bit longer. Thank you very much.